we will take a lot of occasion. I'm not going to tell you about concepts regarding this occasions. Our focus will be our full concentration will be on solving questions. Yeah, all this question will be based on motion in a plane. As you can see, there is a first question in front of us. First step is to understand what is the question asking. What is the question saying to us? What is the question trying to tell us? Okay. Again, I am telling you, I am not going to discuss about concepts of this type of questions because our full concentration during this lecture would be on solving question. With logical, we will solve. Let's read. There is a figure with a question. This figure is the same. A particle is projected. A particle is thrown with some velocity. So velocity is 100 meter. A particle is projected with the velocity of 100 meter per second. Means in 1 second it is covering 100 meter. In 1 second it covered 100 meter. Okay. At angle 37. At angle 37, which means if this object is going like this, so here this horizontal and this, it is talking about this angle which is made by this path and this horizontal line. Okay, 37 degree. How much? With that 37 degree horizontal, with horizontal, you can see it is a clarifying. As shown in diagram, this diagram will be given by the question. You don't need to be worry. First question is asking what is the initial velocity? What is the initial velocity? Initial velocity. Initial velocity. But in the language of vector, you would say if you which means 100 meter with this with the u velocity, stone was thrown. So u is how much? U is 100, and we now for horizontal we say that for horizontal, so this will be our 100 u and cos theta. So theta is given, which is a 37. This is for horizontal. When we will simplify this, we will get a velocity which will be for only horizontal. So let's simplify this. 100 will be as it. 37 value of 37 is going to be it is going to be nothing but I think so 3 by 4. Let's see. Cos 37 is equal to what? 3 by 4. 3 by 4. And this will be our 3 and this will be our 4. 37 by particular base. So 4 by 3. 4 by 5. 4 by 5. 4 by 5. If you put 4 by 5, it should be 100. Result should be 100. 25 is 100. 24 is 100. Yes. So 4 by 5 is the value of the cos 37. This initial velocity for horizontal will be our 80 meter per second. Means the object is moving with 80 meter per second only in horizontal. Okay? Only in horizontal. Now you are able to calculate this this velocity for horizontal because of u is given. With the help of you can also find this y velocity. So this will be 100 sin theta. Sin 37 is 3/5. So 100 multiplied 3 by 5. 5 is nothing but it is a yeah. This 5 is a hypotenuse and 3 is a perpendicular. So 25 is 23 is 60. 60 is nothing but this is a velocity. 4 vertical. 60 meter per second. Okay. So in the language of how to write this velocities in the language of vector, you would say this is I cap, this is a cap. So this plus this will be our 100 meter per second. So answer for this differential velocity is going to be 100 I cap plus 60 j cap. That's it. That's it. Have a look for few seconds, not too much minute. Next question I will take which is acceleration of a particle when it is in air. Acceleration of a particle. Acceleration of a particle when it is in air. You are crystal clear about it. But again, this is my work. I will tell you, I will repeat it again. It is asking what will be acceleration of a particle when it is in air, not with the contact. Okay. Yeah, it can come. It can come with contact of air. You know, if it is in air, it means air is going to be resistance for particle. Remember always, we have seen concepts behind it. Concept says that horizontal velocity is going to be fixed, is going to be constant. Acceleration will be zero. If acceleration is a zero, so velocity will be constant. Means if velocity is a 60, so at any time velocity will be constant for horizontal. But when it comes to vertical, then it is a little bit different. Here acceleration is going to be 10 minus 10 because this is a downward. Acceleration is going to be downward, so that's why minus 10. So this minus 10 is a fixed. When it comes to air, it means a particle is in air. So when particle is in air, so for vertical, when it comes to vertical, we say that a particle is in under gravity. Particle is under gravity. So under gravity, it means acceleration is going to be minus 10. This is a fixed. This is a fixed. So minus 10. So minus 10 z. In the language of you can say like this: minus 10 z. Minus 10 j cap. When it will reach at highest point. When it will reach. When it will reach at highest point. Highest point is going to be this tangent, which is a horizontal. When it comes to horizontal tangent, we know that slope is zero. Slope is going to be zero because of slope is a horizontal. If slope is a vertical, then again slope is going to be zero. Slope is going to be zero. So the third is asking when particle will reach at highest point over here, then what happens? You say that a v is going to be zero. For y, it is going to be zero, but for vx is going to be constant. Okay, constant. It is not asking displacement from ground to the highest point. When it comes to displacement, we say that this is S is equal to ut plus half at square, where u is given, t is also given. T is not given. T is not given. T is not given. So it is asking when it will reach. Try to understand this sentence. This sentence is asking when means time, not where. When this particle will reach at highest point, time. It is a time to now. What is the time? what would be that time when particle will reach at the highest point. So this will be highest point. So here what is the time to reach this particle, when particle will reach over here, then at what time this will reach. So to calculate this, we know here t is going to be 0. Now tell me, here this is going to be 0. In this we have 60 meter per second. In 1 second velocity is going to be velocity will decrease to 10. In 2 second, how much? 20. So at 2 second velocity is going to be 40. Now tell me, what will be that time? It is time to now v will be 0, and what will be time. So we know, if we put here t as a 6, so our solution would be 10 multiple 6, 60, and 60 minus this velocity will be our 0. So time is a 6. Time is going to be 6. So time will be, at this time wave I will become 0. This is what it was asking. Time of a flight. Time of flight. Next question. Time of flight. Time of flight means, what was that time that was taken by the particle just to stay in here. So that time it is asking. That time. So that time means from here to till here. This is half. So this half plus this half plus this half will be our complete time. At in this time, this particle to stayed in air. As we know, from here this is going to be 6. So this is 6 half and this is 6 half. It is a complete time of a flight. 6 plus 6, 12 seconds. In this time, this particle stayed. This particle stayed in air. Now next, fifth. Range. Range. When it comes to range, we are crystal clear about it. Range is nothing but, this is asking displacement of horizontal, not a displacement of vertical. Okay. For a displacement of a vertical, we consider this as a height, maximum height, or you can say height. Okay, but when it comes to horizontal, we said what is the range. So to calculate range here, as now acceleration is going to be 0. If you use this formula, u plus u v plus v is equal to u plus at, then you will get what, nothing but you will get u plus at. You will get nothing but u multiple t. U multiple t. Let's see. V means initial velocity, final velocity. And this ux and vx. Ux is 80, and this will be also 80. This 80. A is going to be 0. A will become also 0. 80 minus 80, 0. Nothing is happening. V is equal to u plus 80. To calculate this range, remember acceleration is 0. Just calculate, just multiply this 80 initial velocity of x by time of flight. So 80 multiple time of flight is 12. Your displacement of your range would be 1. So This is your displacement. This is your range. 960. Velocity at 2 second. Velocity at 2 second. You know, this is nothing but here. In 2 second, acceleration will be 20. So in initial, this is 60 minus 20 will be velocity just for 2 second at 2 second. So 40 meter per second. This is our velocity at 2 second. Remember, at 2 second. At 4 second, you would say acceleration will become 40. So 40, 60 minus 40, 20 meter per second is the velocity at 4 second. Okay. At 0 second, you would say velocity is going to be 60. At 1 second, you would say velocity is going to be 50. 50. Okay. At 10 second, so acceleration is going to be 10 multiple 10 100. So 60 minus 100 will become minus 40 meter per second. This minus is for direction. Direction is a downward. At 10 second, velocity will become minus 40 meter per second. At 4 second, it is going to be 20 meter per second. Now, what if question examiner is asking, write this velocity in the language of a vector? Then you know our this is a u. Yeah, this is u. Just if this is u, can't you say? We are going to write this velocity in the language of a vector. As we know, it is a u. This is a u. So u is equal to ux. So for u cos theta, u is a 40. Cos theta is a 4 by 5. 4 by 5. 4 by 5. 32. 32 I cap and u sin theta is 4 vertical. 40 multiple sin 37 will become our 3 by 5. 24 it is a j cap. So in the language of for this in the language of vector it will become 32 I cap plus 24 j cap. That is how we will write when it comes to in the language of vector. Now next, angle made by velocity. Angle made by velocity at 2 second. You are familiar with this 2 second. At 2 second, our velocity is 40 meter per second. It is asking what will be angle. Angle which means over here. This is our 32 and this is our 24. So it is this is our 40 meter per second. This angle, it is talking about this angle. So we know tan theta is equal to 24 upon 32. 32. 32. This will be your angle. After simplifying this will be your angle, which is this angle. That is, this angle is nothing but this part of rotation. Now let's change the data. Let's change data. Data is the same, 100 meter per second. Data is the same. Location of a particle. What is the location of a particle? Location of a particle. Particle at particular time. At particular time, what is the location? Location means coordinates. It is trying to get coordinates at a particular time. So time is the 2 second. At 2 second, what is our particle? What is the location of our particle? So at 2 second, over here, let's see. So this coordinates of this point, what will be? It is asking this point. So coordinates, it means it is a trying to get now from us to value of x and value of y, x comma y, but at t is equal to 2 second. At t is equal to 2 second. So remember, when it comes to location, then we use third equation of motion, which is v square is equal to u square plus 2s. V is our final velocity. So final velocity, remember, over here, u will become at 2 second, u will become 60 minus 40, so 20, 60 minus 20, 40 meter per second. At 2 second, u became 40 meter per second. Location means this x. B is our final velocity and u is the initial velocity. So initial velocity was 100 and final is 40. Final is 40. Hold on. I am doing yeah. Over here, this is going to be our y. This is going to be our y, and this is x. So x range will become how much? X means this u multiple time. Time is a 2. So x is going to be 2 multiple. Initial velocity is 100. 100. So this will become 200. 200. But remember, here we are not in initial. we are talking about a horizontal. So horizontal initial velocity is 80. This will become 160 meter. It is range. This is range. So range you can say Rx. Okay, Rx. Now y will become displacement, which is u plus half at s square. At s square. So y is nothing but we are going to calculate this displacement where u is uy. Okay, this is uy. So u is 60 and a is 2, a is minus 10. So this is 60 plus a half minus 10, and then t is 2 raised to power 2. 2 5s are 60 minus 5 2 to the 4 20. So 20 not 20 but 40. 40 is a y. 40 is the value of a y. So finally you got coordinates at t is equal to 2 second, which is 160 comma 40. This is your location of a particle at 2 second. But remember, this is ut. Okay, this is ut. So 60 minus 2, it will become 120. This will be 100. Y will be your 100. Now let's calculate next thing. Location of a particle at 10 second. Next, same thing, but time is change. Location of a particle at 10 second. Look at it. X is going to be at 10 second. This is our y, and this is going to be x. X is greater. So x time is 10, and ux is 80. So 80 multiple 10, this will become our x. So 80 multiple 10, 800. Y 80 plus half 80 as well. Ut plus half 80 as well. By using this equation, we will get y displacement, you can say. So u is uy, okay, uy 60, time is 10, minus half, a is 10, a is 10. Now look at over here. Same this formula you can use to calculate x, where this term will become 0. So finally we will have this left term, which is 1 ut. So u is 80 and t is 10, and this term became 0. Rather than using this formula, this 10 multiple 80 came from this equation. This is logic. 60 multiple to 10, 80 is 10 raised to power 2. 2 5s are 600 minus 10 to the 10 tens are 100, 500. So y came out as 100. You can see y displacement is a little bit, where x is a more. So finally you can say coordinate is 800 comma 100, where x is 100, y is x is 800, y is 100. That is why you will find any location of anything at particular time. To calculate equation of a trajectory, we will use a equation which is a little bit different. We never ever studied that equation that I'm going to write in front of you. In front of you. So next it is asking find the equation of trajectory. Trajectory. When it comes to trajectory, equation of a trajectory, there is a one equation that I want to write over here. Y is equal to ut, I think so, ut minus half multiple a t square, at square. We have seen this formula. So t is over here. T is how much? T is going to be x upon 80. X upon 80. T is our x upon 80. When we will put this this t is equal to x upon 80, we will get y. Okay. So y u is 80, u is 60. This is 60. T is x upon 80 minus 1 half 10. Again t is x upon 80. X upon 80. From here you will get you are getting quadratic equation. Quadratic equation. In details, we have a discussion for this in later part. In later part, we will see this quadratic equation with third equation of a trajectory. Whenever you are going to solve based on equation of a trajectory, of course, you will observe quadratic equation. Right now, just I am leaving this till here for you. You solve this ahead of this. Now next look at when vertical will become perpendicular to acceleration means who is the perpendicular? Velocity become perpendicular. So velocity is going to be like this, acceleration will be like this. So here velocity is perpendicular to acceleration. This is a perpendicular to acceleration and angle is 90 degree. So this will happen when Vy will be 0. Then this will happen. At highest point, velocity is going to become perpendicular to acceleration. Here, as you know, this vector V is equal to u plus 80. U plus 80. U plus 80. So u is a u vector plus A vector A. U is 80, I cap. A is minus 10, J cap. A is going to be 6. Acceleration is minus 10 J cap. So finally we are getting one thing. After multiplying, you will see that it is going to be equal to 0. So velocity is becoming 0. And the next A is given for x. And the next A is given. Here ax is a 5 and ay is a minus 10 j cap, 5 I cap. X this question is providing acceleration for x, which is a 5. But remember, if equation is providing ax, then you can put a value of acceleration for x. But equation is not providing. In that case, you have to consider acceleration as a 0 for horizontal, always forever. Okay. Now it is asking to find something that I am going to write. Suppose air start moving such that net acceleration of a particle along x-axis become x is equal to 5. Now try to understand, brother. We are going to write everything in vector, okay? In vector. Can you tell me ui is going to be u vector? Initial ui vector is going to be nothing but, can't you write like this? 80i cap plus 60j cap. Okay, this is your initial u in the language of a vector. Now, what will be your acceleration? What will be acceleration? So acceleration is going to be for x and for y. So x is a 5 I cap and z is a minus 10. Just multiply. You will get something. So what is going to be time? Time we know. Time of flight is going to be 12. At a 6 second, velocity will become 0. Here is where perpendicular, this velocity will become perpendicular to acceleration. We know. Range you can calculate, just multiple. So maximum to calculate H max, we know what to do. To calculate H max, we know what to do. But to calculate a range will be to calculate whatever way, whatever method we were trying to calculate a range. That was right, but that method can be used when acceleration is 0. But here acceleration ax is 5, so method will become little bit it will be changed. So range, it comes to range. So s is equal to ut plus half at square. At square. Where s is a, we are finding this sx, ux, ax. Okay. So ax we don't know. Ux is a 80. Multiple t is a 12. Okay. Half ax is 5, not 10 but 12. 12 raised to power. After simplifying, you will get sx, means this much displacement. This much displacement. Okay. Now tell me, at 2 second, what will be our final velocity? So to calculate final velocity, you know what to do. V is equal to u plus at. V we don't know. U is going to be 100 plus a is 10 minus 10 and time is 2. Time is 2. So our final velocity will become 100 minus 10 to the 20. This is 80. 80. So 80 multiple 3 by 5. This is in your hand. Now tell me what would be our x and what would be our y. What would be our x and what would be our y. To calculate x, what to do? It is very simple. This is very simple. This x. So u is 80. T is 12. No, add 2 second. Okay, add 2 second. Then plus. Here a is how much? Half. A is 5. Ax. I am talking about this ax. T is 2 raised to power 2. 2 raised to power 2. 8 to 2 is 60. 160 plus 1 by 2 multiple 5. 2 to the 4. 20. 2 to is 10. 160 plus 10. This will become 120. 120 is the displacement. This is the value of x. Means at 2 second, this is going to be this x will be our 120. What about y? 80, not 80. Y is 60. This is 60. Uy, okay. Uy is 60. Multiple 2. This will be our minus 10. So 1 by 2 10 multiple times again 2 raised to power 2. Just we replace this 5 by 10. Okay, this 5 by 10. 2 5s are 10. 120 minus 2 to the 4. 5 4s are 20. So it is going to be 100. 100 is the value of y and 120 is the value of x. So coordinates will become x comma y whose values are 120 comma 100. That is how we find. In the previous question, isolation for x was 0, but in this question, isolation is given, which is a 5, and this for y, same, answer is the same. Where isolation is minus 10. In the previous question, isolation was same for y, so that's why result would be same. The result would be same. Now next question, let me write. So first is the question initial velocity. Initial velocity. U. This is velocity which is u. This is the u. Y x I cap z cap. This is our next question. Have a look for a few seconds so that you can analyze. Question is, a particle is projected from ground. This horizontal, this is considering this horizontal as a ground. So a particle which is being projected from this ground with a velocity is not a number. This is variable. Means in the place of u, it can be any kind of number, any number, 10, 100, 1000, 1 lakh. Okay. So this is a variable. Okay. With a velocity u at angle theta. Theta is also not given, and it is asking initial velocity. So you can say that initial velocity for x, it is going to be u cos theta. You can say confidently. Initial velocity for y, for vertical, you would say u sin theta, where u is a initial velocity. So remember, this u in the language of this u is a combination. Otherwise, u is a combination of this u cos theta plus u sin theta. Okay. So finally, you can say initial velocity is u sin theta plus u cos theta. Okay. U cos theta I cap plus u sin theta j cap. I cap j cap, it is for direction. Okay, we are saying that u cos theta is along x axis, u sin theta along y axis. That is how we are telling, we are communicating with this type of equation. Now a solution of a particle will be, a solution of a particle, you would say it is going to be for ay is going to be z is equal to minus 10, which is a downward, direction is a downward. For x is going to be 0, x is going to be 0. Now next we have when particle will reach, when particle will reach at highest point, highest point. So this is nothing but highest point, means v will be 0, v will be 0. So v is equal to u plus 80. Okay, u plus 80. So is v will be as it, u is our, this is 0, u is how much, u is you can say minus a j cap, and t is half, t is half. Half. Here direction is nothing but minus j cap. This is our direction. It means downward. Downward. Now you can substitute some values over here. We become, so uy is how much, u sin theta, and a can be considered as a z. This can be considered as a z, and t you can, this let's say t is this a half, t naught is a half, so t naught from here minus u sin theta is equal to this upon z t naught. To calculate t naught, we can use this equation, which came from this first equation of motion. This equation can be used just to calculate t naught. Okay, to calculate t naught, which is u sin theta. So remember, you are calculating t naught, yeah. So u sin theta upon z is equal to t naught. Velocity at the highest point. So tell me, this was about how to calculate the time. Now velocity at highest point. What will be velocity at highest point? At highest point. Highest point is nothing but this highest point. Over here, what will be velocity? You know this is going to be constant, which is u constant. This is a forever constant. Here u constant. Here u constant. Over here it will be same u constant. But when it comes to y, this is not constant. Okay, for y. So finally, we have said velocity at the highest point. Time also, t naught is equal to u sin theta upon z. Time of a flight would be, this is also easy. Tell me brother, one T naught is equal to u sin theta upon z. This is half. So double of its would be 2u sin theta upon z, which is the time of flight. This is the time of time of a flight. Time of a flight. FLIGHT. Time of a flight. U sin theta upon z. Just we added this to 2. 2 means this 2. Half and half. 2. Okay. So time of flight would be, if question is asking what is the time of flight where velocity is u, then you can say time of a flight would be 2u sin theta upon z, and only u sin theta upon z is equal to t naught. Okay, is equal to t naught. So what is going to be range, brother? Range is nothing but, as we saw in the previous question, this multiplication of u cos theta multiple time of flight is going to be the range, where t is nothing but this is the value t. So u cos theta into 2u sin theta upon z. So to calculate a range, what will be shortest equation? That thing we are going to observe. So over here, u multiplication of u by u will be u square. So u square 2 sin theta cos theta upon z. As you know, 2 sin theta cos theta is a sin 2 theta. I think so. Yes, sin 2 theta. Am I right? I am right. 2. Hold on. U square sin 2 theta upon z. This equation came at the end, which is u square sin theta. So what's the difference? This between the time of flight was 2u sin theta, and to calculate t naught, this was u sin theta upon z, and to calculate r, j is a determinant. J will be as it. Okay. What is the same? U sin theta will be as it, u sin theta. For h, it will become u square. For time of flight, this u will become double times 2u. So t naught will be simple, u sin theta upon c. 2u sin theta upon c is a for time of flight. U square sin theta, u square sin theta. Yes, u square sin theta upon z. It is the equation for using range. To use a range to calculate range. So r is equal to u square. U is nothing but initial velocity. And sin theta, and this is theta. Okay. Z is going to be minus 10. Okay, minus 10. Maximum height will be maximum height will be, it is asking this y. So y is equal to maximum height 80 ut u is a u sin theta. T is how much? In this city, u sin theta upon z. then plus half multiple 80 square. So 80 is going to be minus 10. I think so, minus 10. Minus 10. Minus 10. Or you can say z. Not this equation, but v square is equal to u square minus 2as. So v square is 0, 2 square is how much? U square. U square is u sin theta. U sin u square sin square theta minus 2 multiple again a is how much? A is going to be 0. This is going to be z, and s is a maximum height. We are considering this s as a maximum height. So finally, one equation you will get just to calculate a maximum height. So u square sin square theta upon 2z is equal to maximum height. Finally, HMX came out as a u square sin square theta upon 2z. This equation will be used just to calculate maximum height, where in the denominator it is not only L1z but 2z. U square sin square theta. This is u square sin square theta upon 2z is equal to HMX. So max. For range u square sin theta upon z. For T naught u sin theta upon z, not T naught. Yeah, T naught. Yeah. For time of flight, 2u sin theta upon z. Okay. 2u sin theta upon z. U sin theta upon z is T naught, and for range is u square sin theta upon z. For maximum height is u square into sin square theta upon 2z. These are some equations that are new, and all these new equations came from the previous equation of motion. It's not completely new, but little bit new. These equations will be used according to time.